Okay, so we are going to look at 2.4 part 1. I've split this up into two different sections, and we'll do the first one in this video, and then I'll do another video for part 2. And basically for this first one, we are going to focus on reflections and translations. Notice here I've written SRT for stretch, reflection, and translation. And so basically it's just this part that we're going to focus on first, and we'll leave the stretches to last because it's a little more complicated and there's more to go through when it comes to that. So I think breaking it down will be a nice way to go about this. So when I say stretch, I'm referring to compression and expansion. You've actually done this stuff when you learned about parabolas. So think back to your knowledge of parabolas. You made the parabola narrow, or you stretched the parabola out this way to make it wider. Or you could look at it this way if you're stretching it vertically or you're compressing it horizontally. So you've actually done transformations before. It's just we're going to be applying it to all sorts of different functions this time instead of just parabolas. Reflection is when we flip it over the x-axis or over the y-axis, which would be horizontal. And translations is when you're sliding or moving the graph left to right or up and down. And I've color-coded this so you can clearly see what it is that I'm referring to. If we have some original function y equals f of x, if I apply all of the transformations possible, so stretches, reflections, and translations all at once, this is what this y equals f of x would end up looking like. A and B, the ones in blue, are the stretches. I've underlined them as well because that's also where you would see a reflection, and you would see a reflection if there's a negative posted in either one of those places. And the last one, translations, would be C and D, the stuff that you see in red. So if you don't see any of those things, that would be our original y equals f of x function. So that would be like any function in its basic form. So that's the general overview of what we're going to be doing. And what we'll start with first is horizontal translations. If you have, for example, y equals x squared, I've started with this because it's a parabola, you're familiar with this, and I think it's a nice way to start things off with something you're already familiar with. So if I want to horizontally translate that, here's how it would look in the equation. Instead of y equals x squared, I could write, for example, y equals x minus. Actually, let's make it x plus 1 squared. And let me change the thickness of this. So on the same grid, if this says plus 1, I would do the opposite and move it over to the left to minus 1. So my vertex of the parabola has moved over. And so my parabola ends up now looking like this instead of the original black one that we started with. If instead I had y equals x minus 3 squared, well, if this says minus 3, I would do the opposite of it. So I'm actually going to move it over 1, 2, 3 to the right. That's where my vertex is. And now my parabola ends up looking something like this. So the two pink ones are basically just the black one transformed or translated to the left and to the right. Again, that's review. You've done this before, but it's been a while, so it's good to refresh your memory. We can do the same thing also with vertical translation. So if we have something like y equals f of x, and we do plus d, this is going to move d units up. If I were to do minus d, this is going to move d units down. So notice how in the last examples we did the opposite of what you saw in the equation. That's because we were looking at it like the x was embedded in the equation. But in this case, the d's affect the y values and the y is isolated, so you take it as you see it. So if it says plus d, we move it up. If it says minus d, we move it down. So you don't need to think about in terms of opposites. We only think in terms of opposites when we're dealing with anything that affects the x values. Okay, moving on. Write the equation of a function that translates f of x equals root x by moving it 5 units to the right and 4 units up. So we've got to analyze or look at our equation and think, if it's moving it 5 units right, is that going to affect my x values or my y values? And it would be the x values. And we talked about how if we have f of x equals root, if I want to move it 5 to the right, I've got to do the opposite. So instead of it being plus 5, I've got to do minus 5 to move it in the positive direction. And if I'm moving it 4 units up, well, up and down has to do with the y values, so I would take it exactly as I see it. So 4 up would mean plus 4. Whoops, I meant to do different colors. 4 units up would be plus 4. And so this is what our transformed equation would end up looking like. Okay, using a similar approach, let's do the opposite kind of. So for this next equation, y equals f of x becomes y equals f of x minus 3 plus 5. So what translations have happened for my equation to look like this? The 3 is with the x, so we know we're talking horizontal translation. We can abbreviate that. And we want to say how many, so I would say 3 units. And we want to say which direction. So if this is minus 3, I would say it's to the right. So that takes care of that part. But then I also want to look at that part. So for that part, we're dealing with the vertical translation up or down. If it says plus 5, I would say vertical translation 5 units up. So that's done as well. Okay, if the point 32 is on y equals f of x, which point will be on y equals f of x plus 3 minus 4? Okay, so we want to think of, let's set it up in a similar way. This is our x value. I'm underlining it in pink. And out of this equation, I want to look at what impact this is having on my x values. If my equation says f of x plus 3, I want to do the opposite with the x value, so I actually want to subtract 3 from it. I'm going to put that in brackets there. So my point, instead of 3, if I'm taking 3 away, like meaning if it's at the point 3, 2, so if I were to look at it on a graph, 1, 2, 3, up 2, it's there, I'm moving it 3 units to the left that way, so do you see that we would end up at 0, that means? Using a similar approach, we want to look at what's happening to the y value. So if that says minus 4, that means I'm moving it down 4 spots. And I was starting at 2. So if I'm moving it down 4 spots, that's going to leave me at minus 2 there. So this would be my new point. If this is moving too fast, because I am kind of flying through this, please pause or stop at any point that you need to. This is the nice thing about online learning. You can go at your own pace. If you didn't quite get something, you can go back, rewind it, rewatch it. You could try it yourself and then go back and rewatch it. So make sure that you figure out your method that works for you. That's going to help you to learn this stuff really well. And the nice thing is, when it comes to test time or when we're doing an assessment, it might be nice to have this to refer back to when you're not so sure. Okay, moving on to reflections. This is where we flip it over the x-axis or the y-axis. So if we have a regular function y equals f of x, and I put a negative in front of the whole thing, then this is going to be a reflection. in, we want to decide if it's in the x-axis or the y-axis. So the way I like to do that is look at the negative in front of the equation, and I like to ask myself this question: does that negative affect the x values or the y values? In this case, it affects the y values. So if you think about it, it's flipping it. If it's affecting the y values, it would be flipping it in the x or over the x-axis. Using that same mentality, when I look at this, the negative signs right here, I would ask, does that affect my x values or my y values? It's affecting the x values. So if I had a graphing grid like this, if it's affecting the x values, that means it's got to be reflected over the y-axis. Meaning if I had let's say I had a graph that looks like this, if it's going to be reflected, if it's going to affect the x values and change them to be like this, it's got to reflect over the y-axis. I hope that rough, messy drawing helped to clarify for you and didn't confuse you too much. And if you do need extra help, not to worry, in the tutorials you are welcome to ask me and I can help you with it. So, on to the last one. This is going to affect the y values, and this is going to affect the x-axis, or sorry, the x values. So this is actually a reflection in both axes. Okay, write an equation for y equals x squared minus 4 if it's reflected in the x-axis. Okay, you don't really need to draw this out, but I'm just going to so that we can get a visual. I encourage you to do this anytime you're unsure. It's a good way to think your way through an example instead of just sitting there and being stuck. You've learned graphing so that you could use it as a tool to help you to figure things out. So if we have something that looks like this, and it's reflected in the x-axis, well, this is the x-axis. It would look like that. So if that's happening, you'd want to ask yourself, are you going to make your x negative or does the y need to be negative? Well, if you're reflecting it over the x-axis to make this all flip, you need to make all the y values negative. So a nice quick way that we can think of that or ensure that we've done it properly is write out my equation, but stick a negative in front of the y value. We're not going to leave it like that because we never do. We want to always isolate our y and leave it as a positive. But by doing this, I could say, okay, I got to divide that by -1, divide that by -1, and divide that by -1. So y ends up being negative x squared, and this becomes plus 4. So that's actually what my new equation would be. So maybe here I'm going to say this would be like my negative y value. And this is the opposite. If I'm reflecting it in the y-axis, this would be a negative x value. And the reason why is you'd have your original pink parabola here, and you'd just be flipping it or rotating it around the y-axis. So when that happens, if you think about it, I'd get y equals negative x squared minus 4, and you get to see algebraically how this thing makes sense because it doesn't, look at the thick parabola, it didn't change. It stays in the same spot because this is still x squared minus 4, which looks exactly like our original equation up here. And now you get to see why algebraically that makes sense. Next one, what transformation changes y equals x squared plus x into y equals x squared minus x? This, and you got to know, if you get something like a multiple choice question like this will make your head spin, and you've got to know your stuff well in order to think your way through this. So you have two options here. Either a negative y could accomplish that, or a negative x could accomplish that. And you've got to think of how you would know that. So you have two choices, and you have a few options of how you could try to figure that out. You could just look at it and say, okay, if it's negative y, do you see that this is going to end up being negative x squared minus x? And that's not what this looks like. So it's probably negative x that's going to do it. Let's try it out. Y equals negative x. Oh, sorry. Let's do that to the original. Y equals negative x squared plus negative x. Y equals, well, negative x squared is just x squared minus x, which is what this new one looks like. So yeah, plugging in a negative x is true. So how do we do that? A reflection in the y-axis. If you think about it, you're flipping it over from positive x values to negative x values. Reflecting it in the y-axis or over that vertical line is what accomplishes this. So this is actually what your answer would be. Okay, if 5, 2 is on y equals f of x, what point is on y equals negative f of x? Well, I'm going to start you off with that same question that I like to ask, and that is this negative going to affect the y values or the x values? And by looking at it, it's in front of the whole f of x, so it's going to affect the y values, so it would be 5, negative 2. So only the y value was affected by this. In the next one, I would ask myself the same question. Is this negative going to affect your x values or your y values? And it's only going to affect your x values. So now I get negative 5, positive 2. So I keep that 2 the same here and here. And in the last one, y equals negative f of negative x. They're both negative. Negative 5, negative 2 is what we would get. So there's your assignment for today. It's up to you. If you feel that you're up for it, you can also do the second part of 2.4 today as well. It's totally up to you. I have purposely split them up because I thought it was kind of a lot all in one shot, but you decide. And that's the end, and that's your assignment.